So in this video we're going to look at some more application problems involving trig. Two special terms. We're going to talk about angle of elevation and angle of depression. Angle of elevation is when you're looking straight ahead and you have to move your head up to see a certain object. Angle of depression is just the opposite. You need to look down to see the object. Our example in this video, we'll talk about angle of depression. So let's suppose that you are on at the top of a lighthouse, and I know what you're thinking. That is an amazing looking lighthouse. I agree. I am a great artist, and I understand that you stand in awe of my abilities here. We're going to go with it. So let's pretend that this lighthouse is 130 feet above the surface, and the angle of depression from that lighthouse, from the top of the lighthouse to you seeing a buoy in the water, is 6 degrees. We want to find the distance from the base of the lighthouse to the buoy. So in the end, I want to find, let me get a better color here, I want to find basically this blue line here. I want to find x. Okay, what I know is that my angle of depression is 6 degrees. So angle of depression, if I'm looking from the top of the, I don't know why I'd be at the very top of the lighthouse, but let's just pretend that's where we're at. If I had to look down just a little bit to see the base of the buoy, so my line of sight is going more like this, what they're telling me is the angle created right here was 6 degrees. And so obviously my picture is a little bit exaggerated there. That's not a 6-degree angle, but hey, it fits the space that we have. So angle of depression, you look down to see your object and you measure the distance or the difference from the horizontal to your line of sight. Now, in geometry, if we have parallel lines with a transversal, this is my transversal, the dotted line and the blue line are my two parallel lines. This angle and this angle are alternate interior angles. And if the lines are parallel, the angles have to be the same. So if this is 6, this angle right here is also 6 degrees. You don't have to use that. You could also kind of keep in mind that the angle that's right here would be let's see, this is 90. 90 minus 6 is 84. So this is 84 degrees. You certainly could use that angle as well. So if I am standing right here and I want to know what x is, and I know that this part of my right triangle is 130, from here I know opposite, I want to know adjacent, I'm going to be talking about tangent. So I'm going to use tangent to solve this particular problem. I would say that tangent of 6 degrees equals opposite, which was 130, over adjacent, which we called x. Now, in this case, a very quick, easy trick to remember, if that unknown is in the denominator, after you do all the algebra, you're going to have x equals 130 over tangent of 6 degrees. Those two things just switch spots. For now, I'm not going to explain why. I will gladly go over that in class and show you the algebra behind it. Just ask. Please ask if you want to know. But for now, we're just going to kind of go through and say you are either able to figure it out or you're willing to ask a question tomorrow. So now I just need to make sure my calculator is in degree mode and go 130 times tangent of 6 degrees. And something's not quite right here. Let's see. And I see what I did wrong. I multiplied and I'm supposed to be dividing. So 130 divided by tangent of 6. That should get us a better answer. And I get 1,236.867. And that would make sense. Okay, if you think about, well, I'll go into that in just a second. Let me copy this down. 1,236.867. And we would be in feet. Okay, so I originally multiplied those two numbers and I got an answer of 13.6, and I knew that made no sense in my picture. If this angle right here is really 6 degrees, or if this angle is really 6 degrees, and you think about that size, x should be really, really big in comparison to 130. So my picture is distorted a little bit, but x should be huge compared to this. So I knew that my original answer was not quite right. Okay, we're actually going to stop right here and jot down any questions, and we'll see you in class.